Welcome all again to yet another session. And this session is nothing but extension of yesterday's topics. What we have learned yesterday, we have learned a lot of things, lot of minute things from NXOpen reference guide, API reference guide. We have learned more related to namespaces. We have also seen several classes. We have seen the hierarchy of objects, and we have also seen the interrelationship between those objects, between that hierarchy, which is called inheritance. So we have seen lot of examples of classes and APIs, and the inheritance that showcase the relationship between these different objects. And we have also seen few of the examples, not the new ones. We already knew those examples. We have seen create arc example and create point example. So we can access point collection first, and then we use create point API. Similarly, for arc, we access curves collection, and then we use create arc. And we know that there is uh, not something like line collection, right? So it is only through curves we can create a line, or we can even create an arc from curves collection, not from. There is nothing called line collection. I think there is a line collection, but that does not have an API that we can use for creating line. So we have to use it through create. Uh, we have to use it through curve collection. So this hierarchy is very important to know, because if you looking to find some API and not able to find it out, this hierarchy can help you. So we have also seen the navigation approach, or how to navigate to the specific API. One way is you go through namespace, then class, and then API. If you are very uh, uh, knowledgeable about the namespaces and the classes, then that way is a good way to find the specific API. And that is one of the easiest as well. But when you are going to use that API, you definitely need the knowledge of object hierarchy, because you will find that easily. Is you will find the curve class, but in curve class you won't find create line or create arc API. Create arc, create line API you find in curve collection. And to find that curve collection, you must need to understand the object hierarchy and its inheritance nature. So that is the summary of yesterday's session. Now we'll continue with the same topic, and we'll try to go through several examples to understand more about this structure that we learned yesterday. Okay, so let's start. Let me share my screen. Okay, so this is what we have seen yesterday: navigation, then hierarchy of NX objects, then couple of examples of hierarchy. Collection we have seen, but there is lot more to learn about collections that we will do later. Then inheritance structure of this hierarchy we have seen. Now again also we have seen create point and create arc example, not ellipse yet. So we'll do that today. So, but before that, let's start with expressions example. So for uh, For using this or for discussing this expressions example, uh, what we'll do is we are going to create some expressions in part document. I hope you all of you know about the expressions in NX. With expressions, we can create custom variables, or actually those are called expressions only, and we can have the custom value defined for that expression. We can even have formulas in calculations used in the expression. So we are going to create some expressions via a journal, and we'll see expression collection class, and create expression are two APIs within this class we are going to use. And we are also going to use unit collection class, because there is an option to create expression with units. So if we are going to create the expression with units, we need the unit collection class as well. So we are going to create the expressions in an active part document. So let me move on to NX. I will create a new document, and this is, I think, Visual Basic. I do not need Visual Basic. So I will go to Preferences, User Interface, and select C Sharp. Then Menu, Tools, Expressions. Let's see if we do have any expressions. We have many. Actually, these are dimensions, P0, P1, and so on. These all are dimensions. Those are associated with any of the dimensions. So these are expressions which are related to dimensions. Okay, I know that these are the dimensions or expressions we do have. Now let's uh, let's start Tools, Journal, Edit, and we start with a new journal. Now I will take you through API reference guide first. And in the API reference guide, let me open that guide first. Okay, so I do have this guide. Now let's see where to find the expression collection class. So I can go with this easy option, expression. Expression collection. Yeah, so this is the expression collection class. Now I will find out the API to create the expression. So I can see create. This creates an expression. So let's click here and find out the constructor for this API. It says we need to use create, and into bracket we have to specify the string. And how we can specify the string? The equation for the expression we have to specify inside bracket, and it must be in format name on the right hand side. X is a name, sorry, name is on the left hand side, and on the right hand side a expression. It can be a value or it can be a formula like this. Okay, and what it does, it returns the new expression. So it creates an expression with this kind of format. Okay, so now let's do it. Okay, so I'm ready to start with that. Let me share the journal screen. Okay, now, yes, so we don't need this line. Okay, so UI line I will delete for now. This is not required. And from this line onwards, insert code here. I can go and start writing. So first, what I will do is we need a variable for expression collection. So we'll start with that, and how we can go and create that expression variable is the way the syntax we know. So what I will do is I will start writing expression collection is a type, is an object type. So expression collection is as is, we will use for this variable, and then I will provide identifier. Exps is my identifier name, is equals to work part. Now you can see work part is not yet defined, only the session is there. So part space part space the session, sorry, not the session, work part, its name, then the session. I am cautiously taking care of the case sensitiveness. You can see the S in this, the session is capital because I have used that capital here. So if I wanted to make it small case, I have to change in both these lines. So it will be similar now. So the session dot parts dot work. Okay, so this is the work part declaration. Now expression exps expression collection as exps is given. Now is equals to, what I will do is work part dot expressions. I have to define the expression collection like this, and this is going to be the access point or the value, you can say, we have defined, we have assigned to this variable. Now this line is written. Now I will go and use the create API. So how I can go and create API? Of course, I also need to define that variable before I create that expression object. So what I can do is expression space exp1 is a name of the expression, and I can use semicolon. Assigning object, that is not yet happened, only uh, exp1 is defined. So now exp1 is equals to, I can go and now create the expression. So I know that create API is within expression collection class. So I do have exps as variable for expression collection. So that I used dot create, and then as indicated in the constructor inside bracket, I will use double inverted comma, then name of the expression is equals to, I can even use a formula or I can even use some number. So let's say I will use 25, double inverted comma, then again bracket complete, then semicolon. So this line will create the expression, and the expression name will be x and value will be 25. Now let's try to run this journal. I have executed the journal and will wait whether it works successfully. Something is missing. Part work part is equal to the session dot parts dot work. This is not working. Okay, maybe I have missed something in declaration of this work part. So let me check. Yeah, I do not need this bracket here. Okay, now that part is covered. You might get this kind of errors when you write your program. So we have to understand what is going wrong and accordingly correct that. It says that NXOpen part does not contain definition expressions. Now I understand it. Actually, I have to use E capital. Otherwise, it will not work. Done. No errors. It means our code is executed correctly. Many a times you have to uh, check that whether you have used the correct case, lowercase, and uppercase, because most of the times that can be the error, as we are not used to C sharp. So we have to take care of that. So it is executed and no error. It means that it is run successfully, and it might have created that expression as well. Now let's check if that expression is created. Menu, tools, expressions. You can see this one, x is equal to 25. This is created. Okay, so we are successfully managed to create the expression. Now let's get into API guide again, and go to expression collection. Now there is one more API to create the expression, which is create expression. Now we will try to use this API. So the only difference here is this simply creates an expression without specifying its type. But when we create the expression using this API, it creates an expression of a specified type. So let's see the details of this API. Create expression, and in this expression we first type its expression type as a string. So you can see the type of expression such as number, string, boolean, integer, point, or vector. We can specify this type, and then we can use the other parameter, which is string again, as similar as what we have done in the first case. So let's try to create this expression now. I am into NX again, and here I will go and declare another variable because I want to create another expression. So I will name it as exp2 semicolon. Then exp2 is equals to exps, which is expression collection, dot create expression, and then into bracket, first is its type. What I will do is I will use type as integer, then comma, then again double quotes. This time I will use y is equals to 10, bracket complete, and semicolon. I can use either integer, boolean, string, number, point, or vector, which is very well defined in the create expression help page, API help page. Okay, now I can go and run this journal. But there is one thing which cannot work for me because I do already have the expression with name X. So if I run this journal again, this journal will attempt to create the same expression again, and that won't be possible because we cannot have the uh, duplicate names for expression. So expression name must be unique. So if I go and run it now, it might throw an error. So let's try that. Let's play this journal, and it has given the error. The specified expression variable already exists. So I was right. I cannot create the same expression. I cannot create the expression with same name. So one way is that I can comment this line. So to comment this line, I can use 2 times forward slash. The other way is to change the name of this expression. Instead of x, I can use x1 or something else, because then it will be a new variable which is unique and it will not give an error. But for now, I will comment these 2 lines. I don't want to create the same name, so I have commented this line. And if I am not creating this expression, I do not need exp1 variable as well. So that variable also commented. Now I will go and create this another variable with create expression API. So I will play this journal. It has executed, no errors. It means we have got that created. So let's get into the expressions, and you can see we do have y is equals to 10, and you can see the type is integer because we have defined that type specifically. We got that type. Similarly, we can go and define other things as well. For example, group, even I think comment, status, checks, we can even do that. We can even this dimensionality, I can, I think, specify that as well, and units as well. So this is all possible. Let's get into the API guide again. And go to expression collection class, and this time I will find other way to create the expression. But before that, let's have a look at this expression collection class. We have used these 2 APIs. Then we do have create interpart expression builder. We do have this method as well, which creates interpart expressions. uh, create suppress by expression builder. I'm not sure what is this. There is another API which creates system expression. We can even create system expression by specifying its type, similar to what we have done just now. Then we also have uh, a API to create a system expression with units. And then uh, the general expression with units. So we do have API for that. We even have a API to delete the expression. We even have API to edit the expression, edit with units. So you can see we do have a lot of options and we can do a lot of things with the existing expressions. We can create new, we can modify, we can delete. So many things are possible. Now let's see if I can use delete. Let's use this now. So delete and then expression. So in this case, it is a expression object type. It is not the name of expression. So you might get confused with that. The constructor is similar to other ones like create, but into bracket, we are not specifying the expression name. We are specifying the expression object. Now let me tell you what is object. You already know it actually. Get back to the journal. Okay, now you know that we have the x and y expressions we ourselves created. Now I wanted to delete the expression. Now one way is that, which is a simple one that I will try for now. I will create a expression and then I will delete that expression. So I can delete this line, these two lines. Okay, I will uncomment these two lines. I will keep the expression name as exp1. I will create this expression and then in the next line, what I will do is I will uh, delete that expression. So I think it is going to be not that easy, but let's try. Exps dot delete into bracket expression object, which is exp1. I am creating here the object and then I am simply going deleting that object. The doubt that I have is that I do not have anything like this on this line. So this might create a problem, but let's see if it works. Yeah, it has not. Sorry, I cannot use x, y, and x already used. So I will go and use z here. Okay, it has worked successfully. So ideally, it has created that z expression, and in the next line, it has deleted that. We don't know whether it is happened or not, but how we can confirm is we can go to menu, tools, expression, and we shall not find y here. Y is not here, and our journal has successfully run. It means that z is created, not sorry y, not y, it's z. So z is not there. So ideally, what would have happened? It has created z, and in the next line, it has deleted z. Now, what we can do to have double confirmation about the variable? Uh, what we can do is we can we can use the information window and display some information there so that we know that it is available or it is not. Simply we can try that. So I think I need to find out the way to, yes, so guide dot info write line. So what I will do is guide dot info write line into bracket exp1 dot name. So this is the name of expression, and if we have created z with this line, then we'll definitely able to get the name in the window, and then this delete line is going to delete that expression. So let's see if this works. So you can see z. It means that in on this line, when this line was executed, our program created z expression, and because it has created that z expression, we managed to fetch the name of this expression using this line. Because this line, what this line is doing, exp1 dot name, it means I am fetching the name of expression, and that name of expression is z. It means that was created successfully. So we have got that confirmation, and delete means it has got deleted. If I check the expressions again, I won't able to find it because it is deleted. So this way I can confirm that it was deleted. Sorry, it was created first and then it was deleted. So I am sure that it was there before I deleted that expression. So this way we can go and use any other API related to creating the expression. Let me see if I can give you one more example about expressions. So let's create the system expression now. Let's create that. We can get into the API guide again, and what we can do is let's create the system expression with units. In expressions table, we have seen units column. So when we use this API, then we can specify the unit as well. So let's get into this API, understand more about this API. So the first parameter is string, and it is more or less same how we have defined the variable so far, either a value or either a formula, but we also use is equal to sign. The left side is going to be the name of expression, right side is going to be the value of expression. So the other parameter is unit. So if I click on unit, then you can see we do have unit class. So this is another type of object. Unit is also an object, other object. So we have to use that object. So let's see now how you can use this unit object and create our expression with units. So let's get into the journal again, and what I will do is let's keep it as exp1, and I will copy this API word, API keyword, create system expression with units, and what I need is first is going to be the string. So string means I will use it as z, but this time I will use some formula. Let's say 25 plus 10, and then later on I need to use unit. So what I will do is I will use as unit, but I'm not sure if this is going to work, because what my API guide says, I need to use unit object, but what I am doing here is I am just using a name. It can be a variable name, but I have to define this variable first as a unit type. Then and then only I can use it very well, correctly. So I have to go and define that variable, the unit variable. So what I will do is, just after this expression collection, the type of variable will be unit, unit will be its name, is equals to, similar to how we uh, how we define the value for expression collection or anything similar object. I will start from work part. So work part dot, the same way we have done it for expression collection. So for units as well, we'll do the same. Work part dot unit collection, and dot find object. I have to go little uh, further here. I have to also define what is meant by So that I am doing here, find object, then into bracket millimeter, bracket complete, semicolon. So this way I have defined the unit variable. The type is unit type. Other things are very straightforward. Expression exp1 is the name of this variable, and then create system expression with units, and I think I have used the parameters correct. Now I will not use this delete line. Maybe I will keep this guide dot info write line, because I can print the name of that expression. That is just uh, for the sake of displaying that window. I can even comment this line, because we can go into the expressions window and check that. But let's try now if this works. The only change that we have done is, because that API was required the unit variable, we have defined that variable. So let's try this journal now. Since it has created the expression. Okay, yes, Z is created, which is 25 plus 10, as is, value is 35, its unit is You can see the other two variables which we have created, X and Y, we haven't mentioned the units. So this unit column is blank for these two. But this Z expression, we have used the specific API that can even set the units. So we got unit here. Okay. So this is how we can use the different methods, different APIs to create expression. Okay, fine. So that's all about the expressions. Now let's try with another example. Let me come back to the slides. We have seen expressions, we have seen expression collection. We have not only seen these two APIs, but we have seen lot more. than this. We have seen unit collection as well and unit object type as well. Now let's see and create ellipse. And here what we are going to see, we are going to see this API curves.create ellipse and NX matrix. Create ellipse is very similar to either creating point or creating line or creating arc. The only difference is the input required for creating line are 2 points. The input required for creating arc are different. Start point, end point on arc. It can be 3 points, so it can be other method as well where we specify the radius even. So similarly, the inputs required for creating ellipse are different, but the method is same. So let's try. Let's see that into API guide. So I will go and create ellipse. In create ellipse, we do have different options to create ellipse. This one, we are going to use this one. So in this, you can see what is all required for creating ellipse. We require a center point, which is point 3D. Then a major radius, minor radius, start angle, end angle, then rotation angle, and NX matrix. So I do have this journal with me. Instead of going and typing all that stuff and showing you, I can simply copy that entire code to save the time. Let me copy this. Yeah, so this is the journal that can create a ellipse. So what we need, a center point as point 3D. So center is defined as point 3D, and we do have the values of these coordinates. Then we need the major radius, which is double. Rx is a variable name, and we have its value. We also have minor radius, which is double, and its value is 1000. We do have start angle A0, end angle A1. So start angle is 0, end angle is 360 we require, but NX can only take the inputs in radians for degree. It won't take in degrees. So we have to convert this degrees into radians, and how we do that? Using the formula. 360 multiplied by pi divided by 180 is going to be the end angle. And then we do have rotation angle, which is again 0. And then there is a matrix. Then there is a matrix. Matrix is actually uh, the object type which has a different parameters inside it. Okay, so this is how these all parameters are actually prepared. If we miss to prepare any of these parameters, then it is not going to work. It will give an error. For example, what my API page shows that we need these all major radius, minor radius, start angle, end angle in double type. But if I go and use integer here, integer is int. I don't need this many long values. I can use 25, let's say, and 10 here. And as it is no precision, I can go and use int. Let's see if it works. I will go and hit the play button. Super. It has created, I think, with integer even. You can see this is created. And if I go to the information, we do have major radius as 25, minor as 10. Perfect. So it has created. Now the reason why it has created is uh, there is something called uh, implicit conversion. So we can convert some values into from one type to other type. We have touched upon this topic already. But as this is possible to convert this integer value 25 into double, so that automatic conversion has happened in the program itself. That is called implicit. Implicit means we haven't done anything to to make that conversion happen. So, but it has happened because it is possible based on this value. Let's say now I will use 25 by 5 and 10 by 5. It is not integer anymore. It is going to be the decimal. Let's see if it works. Now you see we got an error. It is meant to be a double because it is trying to convert that into double because that API says it should be double. But as we are using values which are not double, which are integer, it was working. But as soon as we got the value with precision, then in that time it should be double because that won't work. So it depends on the values as well. Implicit conversion means we are not doing that conversion, but we are allowing program to do that conversion if it is possible. If it is possible, program will do that conversion. If not possible, it will not do. But as soon as much as possible, we have to follow the exact type of all the parameters which are mentioned in the API. Then and then only we can guarantee that our API is going to work. I cannot change this sequence. I cannot use some other type than mentioned one because that is not work in most of the cases. Okay. Now last point about this NX matrix. So let's see what is this NX matrix in a API guide. NX matrix. This is the requirement for that API. So we have used it. NX matrix. NX matrix collection. Yeah. So NX matrix. Okay. So NX matrix is actually the metric which do provides the translation and orientation information, and most of the times that is used as a input. So you can see these all are parameters there, x, y, z. uh, when we are going to see the debug, that time I will show you what is exactly NX matrix. But for now you can understand that it represents the orientation and translation information of object. Okay, with this, that's it, I guess. We are done with this example also. So what is required is that when we use that API, we have to prepare all the inputs correctly, and then we are sure that it is going to work. This is same for anything, even if it is point, we need to create the point 3D first. Then and then only we can create a point. So these examples I am anyway going to upload so that you can refer these examples. And for assignment part, I will share the assignment to perform uh, as soon as possible. Okay, so that's it in today's session. We will continue with the next topic tomorrow.